Okay. So I will go with you through problems to cover different new ideas in chapter 4. Let us start with this problem to remember how we can reduce a system of forces into one point and how we can also reduce to a single force. So for example, replace the force system acting on the truss by a resultant force and couple moment at point C. Okay. Since in the YouTube playlist, I already solved this about C, let us change the question. So for example, I can ask you now to reduce the system about A, at point A. So the method is always the same. Whenever you want to reduce at a point, you should move all forces to the point of interest. But we said that to have equivalent system, whenever you move a force to a point, you need to add the moment it's producing about the point. Okay? Plus also, I will add something to the problem. I will consider, for example, that I have a couple at B. And this couple is equal, let's say, to 50 LB feet. Okay. And I will add also another couple at C in clockwise direction equals to 20 LB feet. Okay. And now the question is to reduce the system at A. So first, whenever they specify for you a point and you want to reduce the system at a certain point, you do the following. You say, first, I calculate the resultant force. Okay. And since here I have, my forces have directions in X and Y, I can select any frame. You know, I can take the conventional XY if you want. Or because Y, all forces in Y are downward, you might say, I want to take the frame in this way, X positive to the right and Y positive downward. Okay. So now we have the following. Sum of forces F resultant will be divided into two components, FRX and FRY. So first we compute FRX. If we look at our figure, the only force having X component is this one. So I will take this component as Fx, and it's plus 500 times what? What should I do here? Look, they gave me the following information. This is 3, 4, 5. Okay? When they give you this is instead of giving you the angle. Okay? So you say here, I want to project on X. When I want to project on X, I need to consider cosine of this angle here. What is, if I call this angle alpha, cosine of this angle is 4 over 5. So it's plus 500 times 4 over 5. And this is how I find the resultant in X. I move now to the resultant in Y. So I have FRY equals to, now I have several forces to add. We considered the downward direction as positive. So I have 200 plus 150 plus 100. So the addition is 450 of these three. So 450 plus, you have here a downward component. So you need to project. And since you need to project, you will use sine of this angle. Sine this angle is 3 over 5. So plus 500 times 3 over 5. This is your resultant. And whatever is the point you want to reduce at, so if they ask you to reduce at A or to reduce at B or to reduce at C, the resultant force will be the same. What will just be different is the moment. You know, when I say moment, I want to reduce at A, I should do sum of moments about A. Because when I move a force to A, I should add its moment about A. I should consider the moment it's producing about A. And don't forget, I consider moment of forces and I consider couples. We have seen together that the moment is a free vector.
دكتور
Yes? Yes, tell me.
دكتور
نعم.
كتير عم بقطش، ما بعرف إذا من عندي ولا من عندك، بس
Is
كتير تقطيش.
is it the same problem for everyone? Do you hear me well or not? كمان. بس أنا I'm very close to the connection. I'm directly near the connection. طب I will try to change the connection placement. One second.
Oh,
Is it better now? Dear students, is it better? Do you hear me? Dear students, do you hear me?
yes.
Is it better or same? عم بقطش شوي. طب it's fine يعني I am very close to connection. We'll try to continue. Hope it will be better. Okay? So second step now is to calculate the moment about A. M resultant at A. And we said that to calculate the resulting moment at A, what should we do? We do summation of moment of forces about A plus summation of moments of couples plus summation of moments of couples. Okay? Now, you should select a positive direction.
بعمل point C ولا point A؟
Point A بس أنا بس حط sum MC مش يعني point C. This represent summation of moments of couples.
لا
Okay? نحن we are doing about A here. I
قصدي بس
changed the question because it's already solved in your videos about C.
question
I
كان at
changed
point C.
أنا غيرت السؤال to do a new thing for you because in the
اوكي
videos you
اوكي
have
got it.
already about C. I changed the question.
اوكي
I
اوكي
said
got it.
about A and I added two couples to the figure. Okay? To show you how we account for couples. So in case you have a couple in the figure, the unit of the couple is Newton meter in SI or LB feet in English units, you need to consider them because we said that moment are free vectors. So if you do sum of moment about A, you should consider these two. If you do sum of moment about B also, you should consider them. So whatever is the point you are doing moment about, you should consider these two couples. Okay? Now, you should select a positive direction. Let us consider, for example, that the clockwise direction is considered as positive. Okay? So what do we have here? Let us look at our figure. In the clockwise, we have plus 200 times 2 for the first force. Plus, for the second force of 150, what is the distance to A? Here you just have to take the perpendicular distance. So 2 plus 2 is 4. So plus 150 times 4. Now for the 100 lb force, you multiply by the total distance, which is 6. So plus 100 times 6. Okay. And finally, for this force, we said we'll divide it into two components. Okay, I will draw the two components for you. You consider it's applied at this point. Okay. And you say, I will divide it into two components. One that is vertical and one that is horizontal. Now, since we are considering A, the horizontal component is part. Dear students, do you hear me? Dear students, do you hear me? Sorry, I had a small connection issue. I think it's fixed now. Do you hear me? Test, test. Dear students, do you hear me now?
سامعينك دكتور.
Okay. So we were talking about some of moments about A, and we were discussing the inclined force. So for the inclined force, you have two components, the vertical and the horizontal one, as I illustrated in green. The horizontal component is passing by A, so it cannot produce any moment about A. So we just have the moment of the vertical component. And the vertical component is at a distance of 8 feet from A. So we should add plus, since it's clockwise also, so plus 8 times the force, the vertical force. The vertical force, we have already calculated it before. It's 500 times 3 over 5. So it's equal to 300. So it's 8 times 300. Now, please don't forget to add the couples. So until now, we have calculated some of moment of forces about A. We still have to consider couples. We have two couples in this figure. One that is clockwise, so plus 20, and another that is counterclockwise, so minus 50. Okay, and in this way, we were able to reduce our system to point A. Okay, so now if I want to present my equivalent system, I say I was able to reduce my system to A, and I present at A the following. I have FRX, I have FRY, which is downward, and according to my summation, I get a positive result in clockwise direction. So my moment MRA is clockwise. So I can present my total resultant moment at A, which is a clockwise couple. Okay? This is one possible question to reduce at A. But now we can ask several other questions. We can ask you, for example, to reduce the system to one force only. Okay? But you have several choices here. You don't have only one choice of reduction. Why? Because look, if you want to reduce your system to a single force, you are able to displace your force you can displace it on AC, you can displace it on AB, okay? So you can change the direction of displacement of your force. For example, if I ask you, what is the location of the force, of the single force that will present the system if I want to place it on AC? This means what? This means that I want to reduce now my system to one force acting somewhere on AC. I don't know where. So this is AC. My purpose is to find the location of my force in a way to represent the system alone. Yani I don't need a couple here. This is the question. Okay? I want to determine what is the distance from A. We can call it, if you want, Y. What is the distance Y to move on AC in order to reduce the system to one single force? Okay? Now, how to answer this question? It's really simple. You say the two systems are equivalent. What do we mean by equivalent? They produce the same moment about any point in space. And here, from this figure, what is the moment about A? The moment about A is M resultant at A that we calculated together. Okay? FRX, FRY cannot produce any moment about A because they are located at A. So we can say that in both figures, to have equivalent system, here also the moment about A should be equal to MRA. So now we say, if we want to find the location of the force in a way to represent the system, we say that this force should have the same effect about A. So of course, it should have same FRX, FRY, which is the case because we just displaced the force as it is. So FRX is the same. FRY is the same. But now the force alone will represent my system. Why it will represent the system alone? Because I will move it at a certain distance in a way to create about a moment equal to MRA. So I can say now that MRA should be equal to what? Who can tell me? Who is producing a moment
V
about
times
A?
FRX.
Yes, very good. In this figure, FRY will not do any moment because it's passing by A. Only FRX will do a moment. So to find what is YAC, I say MRA is equal to FRX. But can you tell me something? Is
لا
the
بس
is the
المومنت هذا بيطلع
direction that I
بالمقلوب.
selected right? Is Y downward or upward?
بيطلع المومنت بالمقلوب
Yes,
نيجاتيف.
very good. So please pay attention. I cannot put the force to the downward side. Why? And you can verify this because look, if I displace my force downward, FRX will create about a counterclockwise moment. And this, I don't want this. I want to verify two things. The magnitude is the same and the direct and the sense also is the same. So it's not enough to have the same magnitude. I should have also same sense. And if I displace my force downward, FRX will produce a counterclockwise moment, which is not desired. So this is wrong. My figure is wrong. Then I say, no, I cannot displace my force downward. I should displace it upward. Practically here, I don't have anything, I don't have a material to support my force at. So I can say I should put, like, let's say an extension. So if I put a rod here, an additional rod, I can say I should displace my force upward. Okay. But if I don't have this rod, I can say I don't have a point to apply my force at. I can do another analysis. I can move it along AB instead of AC. I will discuss this. Okay. But if I put a rod, I can say that I can put my force somewhere upward in order to produce the same effect. Now, to determine how much I should move up, I say the following. This is A. I should move my force upward a certain distance. I will call it Y. Y from A, but it's not Y upward here. I cannot move down. And now I should apply my force somewhere here. So now FRX will do about a clockwise moment. Okay, and this is the right scenario. While FRY will not do anything because it's passing by point A. So this is FRY. Okay, so now to obtain equivalent system, I should displace my force upward. And to know what is the distance of displacement, all I have to do is to say that the resulting moment about A is equal to FRX times YA. Okay, and this is how I can calculate the value of YA. So YA is MRA over FRX. Okay, I will add an additional question. Reduce your system at on AB. Okay, now I have to approach here. But let me open white. Okay, so now here I have to approach. I can do the following. I can say that
Doctor,
yes. Yes, tell me.
What is the question they ask us to calculate
Okay. They are
by A?
asking us, I will write it here. I will type the question. Okay. The first question I asked you is to reduce the system at point A. Okay. So when I tell you to reduce at a point, what do? You find the resultant force and you find the resulting moment about A. Okay. Second question, reduce the system to a single force acting on line AC. Okay, this is the second question. Now I will add an additional question. Reduce the system to a single force, but now acting on AB. Okay, and I will illustrate this in a figure now again. This is my structure. I'm sorry for this. Do you hear me again? Dear students, do you see the screen again? Test. Dear students, do you hear me? Dear students, do you hear me?
Yes, we can.
Okay. So I added two questions.
Yes, doctor.
Okay. I said reduce the system first at A. Okay. Then reduce the system to a single force on AC. Then reduce the system to a single force on AB. Okay. The first step was to reduce at A. When we did the reduction at A, we got the following. We got a force in X. Okay. We get a force in Y. And we got also a resulting moment, okay, in the clockwise direction. So this is M resultant at A. Okay, this was the first question. Okay, now, second question, I want to reduce the system to one force, to a single force. Okay, and this single force should act along line AC. This means that I should displace my force on AC in a way to create the same moment about A. Okay? Now, to know if I should displace it up or down, I should look at the direction of my couple. My couple is clockwise. So if I can try. If I displace my force downward, okay, if I put it here, what will happen? It will create a counterclockwise moment. And I don't want this. This is why we said we should displace the force upward. Okay? If I displace it upward, I can find one possible point on AC in a way to create the same moment about A. So now my new scenario is the following. I want to place my force. So this is line AC, okay? This is line AC. I want to move my force along line AC to produce the same moment about point A. And we said that we should displace it upward, okay, to create this moment. So I need to put an extension rod for AC if you want. And then I can put the force on a certain point here that I should determine. So the question is to determine what is the distance from A I should apply my force at to create the same effect. So then at A, I don't need any couple. I just need my single force, which consists of FRX and FRY. Okay. So now let us look at our figure. As we said, FRY is not producing any moment about A. We only have the moment of FRX. So the distance we should displace our force with is YA equals to MRA over FRX. Okay? Clear? Question on this? Okay. Now, if you want to reduce your system to a single force along AB, so this is line AC, this is line AB. Now we want to displace the force along AB. So first we should ask ourselves the following question. Should we move to the right or to the left? Who can tell me? What is the purpose? To produce a clockwise moment equal to MRA. If I move my force to the right, and I put my FRY is producing a clockwise moment. And this is what I want. So I can say now that when I displace my force on AB, FRX is not doing any moment now. The only force that will do moment when I displace my force along AB is just FRY. Okay. And because of this, I can consider that the distance to determine, I will call it X from A if you want. The distance I should displace from A in the right direction is in a way that MRA is equal to XA times FRY. Okay. And in this way, I can find that the distance to displace along AB, XA is equal to MRA over FR1. Okay, clear? Now, I can solve this question by another way. What is the second method? The second method is the following. Once I find the location on AC, okay, I found one point for which I can reduce my system to a single force. But if you remember yesterday, we were discussing the following. We said that if we have a force F, okay, and we move it along its line of action, so if we displace it along its line, its moment about A will not change, okay? How we can benefit from this information? So let me draw it again for you, okay? This is line, so this is line AB. This is line AC. And this is line AB. Okay? We said that if we displace the force upward, we can put it at this location here, okay? In a way to create a moment about A, the desired moment about A. So let's say this is our force, okay? Let's say this is our force direction, okay? Of course, it's not to scale here. So now I can say the following. Once I know what is the value of YA, I can deduce XA. You know why? Because as we said, if you have a force and you displace it along its line of action, and if you put it anywhere along this line, it's more test. Okay. So we were saying that if we displace a force along its line of action, nothing will change. Okay. So once I determine the location of the force from A, I can deduce its location on A, يعني distance from A along AC. I can deduce its location from A along AB. Why? Because look, if you know YA, you know this distance. And since you know FRX and FRY, you can calculate this angle. Okay, this angle theta here. I will call it theta. How we can calculate theta? Theta is
دكتور
10
مش مسموع
minus
شيء.
1. You can't hear me? Test, test. Dear students, do you hear me? في حدا قال مش مسموع شيء، ما حدا عم يسمعني؟
I can't hear very well.
طيب. Look, يلا, look, this meeting will end. We'll open another one. Maybe it will be better. But let me finish just this idea. Okay? So we have theta is equal to 10 minus 1